ancient skywatchers tracked the exact motion of 5 planets, Mercury, Venus, Mars, Jupiter, and Saturn, with naked eyes, thousands of years before glass lenses existed. No telescopes, no computers. Only eyes, patience, and math sharp enough to predict eclipses decades in advance. Sounds impossible. By the end of this video, you will know exactly how they pulled off this feat. Picture Babylon, around 700 BCE, during a period historians call the Neo-Babylonian era. Priests climb a stepped tower called a ziggurat each night, carrying wax tablets to record whatever crosses the sky above the barley fields and date palm groves outside the city walls. Below them, the Euphrates River carries traders and farmers toward a city built on strict routines, planting seasons, flood cycles, tax collection tied to the moon. Now picture Egypt, a few centuries earlier. Priests along the Nile watch for a single star named Sirius to rise before dawn because this single sighting tells the entire kingdom when the flood season starts, and floods decide how much grain the whole region will eat the coming year. The sky above these cities holds answers every farmer, king, and priest depends on. Here is a fact sounding impossible. Babylonian astronomers tracked the planet Venus for over 1,000 years, recording its rise and fall on clay tablets night after night, generation after generation, eventually working out that Venus repeats its pattern roughly every 584 days. They predicted eclipses to within a few hours of accuracy, centuries before anyone understood why an eclipse happens. They mapped Mars, Jupiter, and Saturn well enough to know when each planet would appear to move backward across the sky, a trick called retrograde motion, all without a single lens. No glass, no electricity. Only patience stretched across centuries. So why bother? First reason, survival depended on the sky. Farmers needed to know when floods would arrive along the Nile or the Tigris, since early or late floods ruined entire planting seasons. Priests linked planting seasons to star patterns rising before dawn, then measured flood height using a stone gauge called a nilometer to estimate the year's tax rate. Miss the timing by a few weeks, and a harvest fails. A failed harvest meant hunger for an entire city. The sky provided a fixed calendar, visible above every village, impossible to erase or lose. Second reason, power depended on prediction. Kings paid astronomers to read omens in the planets, and entire libraries of clay tablets recorded which planetary positions meant good fortune and which meant disaster. A red glow near Mars might warn of war. A bright Venus might promise a good harvest. Rulers who predicted these signs correctly gained trust. Rulers who guessed wrong lost their thrones. Sky reading turned into a job with real political stakes, and this pressure pushed observers toward sharper, more careful record keeping. Get a prediction wrong, and heads rolled. Get one right, and a career flourished for decades. Compare this to modern astronomy. Today, a spacecraft such as NASA's Juno orbits Jupiter and beams back close-up photos within about an hour, the time light needs to cross the distance between Jupiter and Earth. Back then, a single planetary position took decades of nightly notes to confirm. Modern astronomers use math built on calculus and physics developed only after telescopes arrived around 1608. Ancient astronomers built their own math from scratch, using geometry and pattern recognition alone, centuries before anyone owned a single lens. The tools changed completely. The goal, predicting where a planet will sit in the sky, stayed the same. One truth never changed. Patient observation always beats a lucky guess. Here's a detail most people miss. Ancient astronomy gets painted as guesswork dressed up as religion. Wrong. In 585 BCE, a Greek thinker named Thales predicted the exact day of a solar eclipse, stopping a war between two armies who saw the sudden darkness as a sign from the gods, a moment many historians call the first recorded scientific prediction in history. Babylonian records show planetary predictions accurate to within a day, centuries before most Greek philosophers even started writing about the stars. A Greek astronomer named Aristarchus proposed that the sun sat at the center of the solar system, not Earth, over 1,700 years before Copernicus published the same idea. Ancient skywatchers were not primitive. They were precise, and modern retellings often erase this precision from the story. Now let us break down exactly how they managed all of this without a single piece of glass. Segment 1. The sky worked as their laboratory. No screens, no light pollution, no clouds of city smog to block the view. A clear desert night over Babylon or Egypt showed thousands of stars in sharp detail, far more than most city dwellers see today. Planets stood out because they moved. Stars stayed fixed relative to each other, tracing the same patterns year after year, decade after decade, century after century. Planets drifted against this fixed background, and early skywatchers noticed the difference within a few careful seasons of watching. A dark sky beats any lens, no matter the era. Segment 2. Symbol tools sharpened raw eyesight into precision instruments. A gnomon, a plain vertical stick planted in the ground, tracked the sun through a shadow shrinking and growing with the seasons, marking solstices and equinoxes to within a day or two. A merket, an Egyptian sighting tool built from a strip of wood and a plumb line, let priests line up a star against a fixed reference point each night. Sighting tubes, hollow reeds held up to one eye, narrowed focus and blocked stray light, sharpening the edges of faint stars. Later astronomers built the armillary sphere, a set of nested metal rings representing the paths of the sun, moon, and stars, letting observers read angles directly off a physical model rather than the open sky. None of these tools magnified anything. Each one simply measured angles with far more precision than the naked eye alone. Segment 3. Fixed structures turned the sky into a measuring grid. Astronomers built temples and monuments aligned with specific stars or the rising sun on key days. Stonehenge marks the summer solstice sunrise almost perfectly, off by only a fraction of a degree after 4,000 years. Egyptian temples line up with specific star risings tied to the flooding of the Nile. In Mexico, a tower called El Caracol at Chichen Itza lines up with the extreme rising and setting points of Venus across its 8-year cycle. These structures functioned as fixed markers, showing the exact day a planet or star crossed a set line in the sky. Stone does not drift. Stone does not lie. Segment 4. Record keeping turned single observations into real science. One night of watching Venus tells you almost nothing. 1,000 nights, recorded across generations, reveal a pattern. Babylonian priests wrote nightly sky reports on clay tablets, a system called the Enuma Anu Enlil, and archaeologists have recovered over 1,000 of these tablets from ruined libraries. These records stretch back for centuries, passed from teacher to student, building a dataset no single lifetime was able to produce alone. A career lasted decades. The record-keeping lasted dynasties. Later, the Greek astronomer Hipparchus pulled centuries of this data together and cataloged the positions of over 850 stars by hand. Segment 5. Math turned raw data into prediction. Babylonian astronomers noticed lunar eclipses repeat on a cycle close to 18 years and 11 days, a pattern now called the Saros cycle, built from 223 lunar months. Once they spotted the pattern, they predicted future eclipses using arithmetic alone, no telescope required. The same method applied to planets. Track Venus long enough, and its position repeats roughly every 8 years. Spot the cycle, and prediction becomes simple counting instead of guesswork. Centuries later, the astronomer Ptolemy compiled this entire tradition into a single work called the Almagest, a math model so useful, astronomers relied on this model for over 1,400 years. Segment 6. Retrograde motion puzzled early skywatchers for centuries. Every so often, Mars appears to slow down, stop, and drift backward against the stars before continuing forward again, a loop stretching across several weeks of nightly viewing. Ancient astronomers had no idea planets orbit the sun on different paths at different speeds. Greek thinkers solved the puzzle anyway, building a model called epicycles, small circular loops layered onto larger orbits, matching the backward drift almost perfectly on paper, centuries before anyone understood the real cause. Wrong theory, right predictions. This combination carried astronomy forward for over 1,000 years. Segment 7. Different cultures built the same science through separate paths. Chinese astronomers logged comet sightings and eclipses for over 2,000 years, engraving early records on a bone and shell as far back as 1300 BCE. Records so precise, modern scientists still use them today to study ancient supernovas. Maya astronomers in Central America tracked Venus with a calendar accurate to 2 hours over 500 years, preserved today in a book known as the Dresden Codex. Egyptian priests built star charts tied to their calendar system and divided the night sky into sections called decans. None of these groups shared notes across oceans, yet each group reached similar methods: watching, recording, repeating, predicting. Separate continents. Same solution. Segment 8. This ancient work still shapes modern astronomy today. Centuries of Babylonian eclipse records let modern scientists calculate how Earth's rotation has slowed over time. Greek geometry, built to explain planetary motion, later shaped the math Newton used to describe gravity and the math Kepler used to describe elliptical orbits. None of the tools survived unchanged, but the questions and much of the underlying data carried straight through to today. A shepherd counting eclipse cycles in Babylon and a scientist steering a modern space probe share the same starting point: patient observation of a moving sky. So here is the full picture. Ancient astronomers tracked planets using simple tools: fixed structures, patient record keeping across generations, and math built from pattern recognition rather than physics. They had no lenses and no computers, only sharp eyes and centuries of careful notes passed down through entire cultures spanning 3 continents. The sky rewarded patience long before technology entered the picture. Thousands of years of watching turned a random point of light into a predictable, moving object. And this shift changed how humans understood their place in the universe. Would you have spotted Mars drifting backward across the sky without a telescope? Drop your answer in the comments below. If ancient science like this catches your attention, subscribe for the next breakdown of how early humans figured out the world around them, one careful observation at a time. Humans have studied the sky for thousands of years, and this story continues today.